Last night's workshop recording, when I gave an introduction to Nina, didn't work properly, so it's given me the opportunity to re-record it. I wasn't happy with the presentation, so I'm going to hopefully make it more digestible this time. The way I use Nina is depicted with a simple diagram. So this blue box represents the telescope, and above the telescope I've got a Windows 11 small computer about the size of a mobile phone, and that connects all the peripherals of the telescope by USB cables. I sit in the house using a normal desktop, and it connects using either Windows Remote Desktop or Teamworks, or you can also use Chrome. If you've got a Seestar, then you can connect that to Nina. In order to do so, you need four things. You need the latest Seestar firmware loaded. It needs to be in equatorial mode, so you need a tripod that's got a tilting head. You need to connect the Seestar either using its own hotspot or change to station mode when you can use your home Wi-Fi. And finally, you need on your PC Nina and the ASCOM platform installed. So we'll get going. So the first thing I'm going to do is connect to the computer on the telescope. So I'll launch TeamViewer. I think I said Teamworks before, but it's TeamViewer. So hopefully there's my small computer, which I call Astro. So I click on the connect button, and a moment later hopefully it will connect. So I need to log into the remote computer, and I'll just rearrange the window so it's full size, get rid of the top bar and get rid of that so it looks like the normal desktop that I'm using. So when I launch Nina, the first thing that happens is it opens up a list of profiles. Because I've got different telescope, I've got a Mac reflector. I use that sometimes with an ASI colour planetary camera. Sometimes I just use the Canon camera with a 300mm lens, but I'm going to open up the refractor, the 72mm refractor with the QHY mini cam. This takes a moment, so I'll speed it on. So once it's up and running, it takes me straight off to the equipment menu. The main menus for Nina are on the left hand side here, and we'll have a look at each of those items as we go along. So for the equipment menu, I've got a list of all the equipment that I could connect. So the first thing I'm going to connect is the camera. I can't see the QHY camera at the moment, so I'll click on this to refresh it. And now it's appeared the QHY minicam. And when I click on this button, it will load. While I'm waiting, I can do the same for the filter wheel. Need to refresh that again. It's found the filter wheel, and I can connect that. When you connect the devices, if there's any configurables with that device, they'll appear on the screen. So at the moment I'm on the luminous filter, so I could change that to let's go for red, change the filter. If you're using a Seestar, your camera option, I'll just disconnect my camera at the moment. Your Seestar camera would appear in this list underneath the ASCOM devices, so you would just highlight it and then click on the connect. You'd also have a filter wheel for the Seestar, so you can change the filters. You would also have a focuser and your mount. For my mount I use the ASCOM called Green Swamp server. And my focuser is a zoo focuser. I can connect that, and I'll connect my light panel, sorry, my flat panel, and I'll also connect to the weather. And the weather app I use is called Open Weather Map. So that's me connecting each individual device using selecting each one and then connecting to it. There is a quicker way, and that's this big button down on the left hand side. So if I clicked on that, it would actually connect all the devices which I use on my imaging train. And as each device is connected successfully, I get a box appearing over on the right hand side, and this is the PhD application for guiding, which we'll not be looking at today, so I'll just drop that out of the way, and I can close all these successful information boxes. So the next stage, I'll go into the imaging menu, and this is a very flexible, it's the console where you can see what's going on your telescope. There's a number of areas where you can put information. So along the top here are the bits of information that you could be viewing at any one time. So at the moment I'm looking at my filters, and they are appearing here under this tab. But if I didn't want to look at the filters, I could just tick that, and that option has now disappeared. I'll put it back on, and that window, that little window pane, I can actually move that around and put it anywhere I like on the imaging window. I'm going to put it back to where it was because I find that the most useful. I've just taken a 3-second image. What I should have shown you is, before I did that, I checked my flat panel and made sure it was open. I'm going to go to the camera settings and set the temperature cooling to -10 and hit the cooling button. Now over on the focuser, I'm going to move it over on the fast move, I'll take a picture to see what that looks like, and as you will see, it's now gone out of focus. So I'll move the focuser back and take another image. And we're back in focus. But just to double check, I'm going to start an autofocus routine. I'm going to speed this up, and what's happening is it's taking a number of images and plotting them on a graph against the on the x-axis is the position on the focuser, and the y-axis is the reading of HFR, half flux radius, the size of the star. So the smaller the star, the better focus it's in. So I'll whiz this on a little bit. And there you can see it's given me a nice U-shape curve, and it's found the focal point to be at the bottom of that U shape. There we go. Because there's no stars at the moment, I'm going to run a bit of video that I recorded a couple of years ago. That's using the same OTA but with the Canon camera one-shot colour connected. This is how polar alignment works. So I've opened the 3-point polar alignment tab, and at the top I've added my settings. So I think, I can't see from here, but I think it's 3 seconds. And I've told the mount to start at its current location. And when I hit the go button, what will happen is it will start taking images and plate solving them. It's a very cloudy night, hence the reason why the stars look a bit fuzzy. So it's found, I managed to plate solve the first image, and it's trying to plate solve the second image now. And it's succeeded. It's going to move the mount just slightly around a bit and plate solved again, and it's telling me that I've got these errors, so I would need to move the mount a little bit to the left, a very little bit down to the bottom. Because it's so cloudy, I'm going to leave the polar alignment at that. Normally I like to get within about 2 minutes error. Using a Seestar, because it hasn't got guiding, the better your polar alignment means that you'll probably be able to take images a lot longer than if you're not on polar line. So the next thing we're going to look at is how to acquire a target, and there's a number of different ways of doing it in Nina. But first, because it's obviously daytime at the moment, and you can probably see my telescope over my shoulder, I'm going to go into equipment, and I've already set it to use this Nina simulator camera. When you set it into simulation mode like this, if you go into the settings, there's 4 options. I'm using Sky Survey, so what that does, it pulls down an image depending on where your telescope is pointing from the internet and displays it. Something you should know is these images are pre-stretched, so if you leave the stretch on in Nina, you would be double stretching them, hence the images will look blown out. The settings for it, I've kept it as my normal QHY camera with a default gain of 78 and the offset of 15. So the first way we're going to look at acquiring a target is in framing. So over here in the coordinates I can look for a particular object. So I'm going to look for Bode's Galaxy M81, and there it's found it. And when I click on load image, it will take this centre image and place it where Bode's Galaxy is. That rectangle you can see is the field of view of my particular camera, which is set using these parameters, and these are wrong at the moment. Around about 3820 by, I think it's 25 something, and the pixel size is 2.9, but the focal length is 420. So that's what Bode's Galaxy would look like on my telescope. So I can go over and slow and centre the telescope to it, and hopefully over my shoulder you'll see the telescope move. Nina's now going to take an image and plate solve it, and from the plate solving it will work out the error distance for both RA and DEC. So it's found the errors to be 5 seconds and 4 seconds, which is well within my tolerance, so it will stop at that. But if it was a bit further than that, then it would move the mount, take another image and keep doing so until it's framed exactly how I want it. And you can see that the camera rectangle is sort of square on at the moment, but it's probably not like that on my telescope. So I can determine the rotation of my camera by clicking that button. So again, Nina's taken another image and it's going to plate solve it and work out the exact orientation of my camera. And there it is, it's just slightly off from the way it was. And close that now. If I've got a camera rotator, or if I set the rotator to manual, what I will be able to do is move that frame to exactly how I want it. So if it was manual rotation, if I want to get all 3 galaxies in like that, if I was set to manual rotation, Nina, when I next take an image by pressing slew and centre, Nina would tell me that I need to move my camera so many degrees in any which direction. If you've got an automatic rotator, then it will just move the rotator and line it up as per the way I've set the rectangle. So again, it's well within tolerance, so it won't go any further. If we look over to the left at the bottom, we can see my horizon, which I've inputted through the settings, and we can see where the target is now. And if I click on this little toggle switch, I can show where the moon's going to be tonight. So I wouldn't want to be taking it images after sort of midnight, because the moon's going to be a big problem. Having acquired the image, the next thing to do is add it to a sequence of images. So if I hit the add target to sequence, I'm only going to be using the legacy sequencer. The advanced sequencer I'm going to leave to people with more a video of somebody who knows more about it than I do. I've only just started using the advanced sequencer, so I'm the wrong person to demonstrate it. So if we go into the legacy sequence, we can see that it's already put one element of a session in. So I can change the number of images it's going to take, so I'll just change it to 2. I'll leave it at 1 second, but in reality, if you're using a Seestar, you'd be setting it anything up to 60 seconds. Because I've got guiding, I can put that up to anything like 5 minutes. The type of image that it's going to take is a lite, that's opposed to either a flat dark bias or just a snapshot. The filter I'm going to use on this occasion, I'm going to go for red. Leave the binning as it is. Because we haven't got guiding, then I can't do this, so I'll leave that it is. Gain and offset, it's taken it from those defaults which was called the camera when it was initiated. And again, we can see what the position of the target is going to be depending on the time of day and in relation to my horizon. The target name at the moment is M81, but if I wanted to change that, I could go over there and put M81 bold just in case I forget what it is. And if I want to add more take more images to this sequence, I can press the plus button. So I'm going to add another set, which will be green, and another set to that, which will be blue. And if this was my last set of the night, I would probably whoops, I did too many. I'll turn that one off. I'll take that last one to blank and call it a dark. So in reality, that for me darks, I would take probably 10 or 20 darks, set at the same length of time as my images. So when I hit the go button, it will start taking the exposures, and you can see bottom left it's doing that. If we go over to imaging now, we can see the images that it's taking, and if we look at the sequence tab, we can see how far advanced we are in the sequence. They're looking blown out because it's stretching the image, which in reality you wouldn't. That's better. You wouldn't see them like that in normal working. Yeah, it's automatically stretching them for some reason. Now, if I look at the image history, this tab on the bottom left, I can look at all the individual frames that it's taken and highlight one, and it will show that image here, although they all look the same at the moment. If I decide that image isn't one that I want to use, I can, instead of giving it a thumbs up, I can give it a thumbs down. And that will change the name of the image. There we go. And it's put the word bad into the file name. So that allows me to filter out any bad images when I look at the result of the sequence. before I even start stacking. Okay, the next way we're going to look at it is using the built-in Sky Atlas. So click on that. So to use the Sky Atlas, pick it off here on the left-hand menu again. I can either type in the name of a target at the top. So as it's suggesting, let's look at M31. And if I search for M31, it's obviously only going to find one item. It's got quite a powerful filtering system here. So because it's today, I could say I only want items which are 60 degrees above the horizon come astronomical dark time. Be visible for at least 3 hours. So with that filter, if I clear M31 out of there and then search, it should bring me back a list of potential. So there we can see the targets that it's found come dark time tonight, which are going to be above that setting of, what did I say, 60 degrees above horizon. So if we went for, let's say, this one, I could add it direct to the sequence or set it to the framing assistant. So I'll set it to the framing assistant for now. Load an image. That's what we would expect to see. And so I could then slew and center and then add the target to a sequence. There's another way of finding targets. That's using this on screen. It's like a planetarium. If I use the mouse, I can zoom out and I can see what also is available in that area. I think I just spotted the bubble nebula somewhere. Oops. Where's it gone? Lost it. But as you can see, you can move around and pick a target. So let's go for, what's this one over here? So because this is a larger target, I can use a mosaic. So to use mosaics over here in targets, you can add additional panels. So let's make it a bit higher and a bit wider and a bit wider still. So now I've got 6 panels, and you can see that they're overlapping, and that's the amount of overlap is the percentage which you can configure in the settings. So when I add that now to my, as a sequence, to the legacy system, you can see I've now got all the different panels up here. So in order for this to work, I would need to, in the target options, tell it to slew to each one. So for that one there, I would need to set that to slew. Come on. I need to set that one to slew. And that one, I'm just going to leave it at 3. So, get rid of that one. Get rid of that one. So I'm just doing the 3 panels, just to make things simpler. I'll delete the bows one as well. And then I would go and set how many I'm going to take of each. So if I'm using a one-shot colour camera, I would only need 1 row of images. So let's take 2 of each. So now when I hit the go button, hopefully you won't see it, but you might hear my telescope slowing to that target. It's allowing the telescope to settle. It's now downloading an image. So if we go to imaging, we can see what's going on. So that's the first set that it's taking. The telescope's moved now to take the next set. Of course, in real life this would probably be taking an hour or 2 to take all the images, and that's the 3rd set. So the 3rd way we're going to look at obtaining a target is by using a planetarium app. So in order to do that, you need to go into options, and under equipment over here you've got planetarium, and you've got a list of options to choose from. So I prefer to use Cartisil. I find Stellarium a bit hungry on the processor, but Cartisil seems to work better. So having set that up, if you then open that piece of software, so I'm opening it up, it's also called Sky Chart, just in case you get confused. It's Cartisil, but on the toolbar it's called Sky Chart. If you find something on the planetarium that you'd like to make as a target, let's say M13 here. If I right click on it, I need to clear the previous target, but if I right click on it, I can set the target to M13. Now when I go back into Nina and go to the framing window, there's a button here which is to get the coordinates from the planetarium. So when I click that, it should pop up here with the name. M13, and there it is, it's moved to that target. Just something else I want to show you in the sequencer. At the moment we've been putting either one or a number of rows of instructions, and that's been one after another. But another way of doing it is to loop. So I can say loop for 3 iterations, and I'll use the sulfur filter for that one, and add another hydrogen. So now when I press go, what will happen is it will take this, then this, and then repeat until it's done it 3 times. So the next way of acquiring a target is working on the assumption that you've already taken some images of something and you want to add some more data. So to do that, we go to framing again and change the source of the image to be from file, and then when you hit load image, it will open up your filing system. And I've already been here, so I maybe want to take some more images of Bode's galaxy. So if I go into that file, we'll go for the green ones, any image will do, and open that. Now it will ask you if you want to plate solve it, and you say yes. The framing will now take you to your previous framing of Bode's galaxy. So all you need to do is slew and center, and then add a target sequence and start taking some more, with the knowledge that you are taking the same image in the same way that you took it previously. It could have been a previous night. And the final way of I'm going to show you of obtaining acquiring a target is to use this button up here, which is simply to get the coordinates from the current location of where the scope is pointing. So for some reason you might have been nudging it with your controls. So I've already set my telescope back to its home position, which is looking towards the North Star, and there it is, there's the North Star. Right, moving on now. One thing that Nina doesn't have is live stacking, but there's a simple workaround so we can get live stacking available. So what I've done here is I've set up a frame around Andromeda and its neighbour M110. I've already slewed and centered to it. I'm going to add the target to the legacy sequencer. I'm just going to take a 1 second image. When I go to the imaging tab, there's the picture I've just taken. If I hover over that picture in the image history, it gives me the directory of where that image has been solved. So it's in Nina, and it's an M31, and then in a folder called lite. So if I go now to Cyril, and set the working directory to that lite folder. So it's M31 and lite. We'll just look inside it. That's that one image I've just taken. So I'll go back to highlight lite, click on open. So that's now set as the working directory. Next to the working directory button is a live stacking session button, and what that does, it looks at that working directory, and every time a new image appears in that folder it will stack it. So if we go now back to Nina and the sequencer and add some more data, so another row of data, but this time I'm going to do say 20, and they're going to be 5 seconds long. Unrealistic, but just for this exercise. When I start that and then go into Cyril, there's the image, and you can see that on the right, every time a new image is going in, it's being stacked. So that's how you quite simply can add live stacking to Nina. So just to look down the menu list again, and we'll see what we haven't covered. So we've covered equipment and Star Atlas and framing. The next is Flat Wizard, and it is what it says. It's a wizard about taking your flats after a session. So here we've got the target name, which defaults to Flat Wizard, but you could call it whatever you want. We'll just call it flats. Number of flats to be taken, and if you want you can also take darks. If you're using a flat panel, something maybe like your iPad, or probably just pointing it upwards to the sky, you can get your scope to slew to the zenith. When you're taking flats with a wizard, you've got two main options. That's either dynamic exposure or dynamic brightness. I don't really have any idea what sky flats are. Need to look at the instruction manual for that. So dynamic exposure means that the exposure time will be calibrated by Nina to be exact to meet your requirements, which you set as a proportion, as a percentage of the histogram. So normally you would set your flats to be somewhere between 30 and 50% along the histogram. I've got it set for 50, which a lot of users do. So the point on the histogram will be at 32,000 plus whatever. I've also set a tolerance of 10% to that. So when I run the flats wizard, what will happen is Nina will change the time exposure until it's hitting this histogram target. Now the opposite way of doing that is if you've got a controllable flat panel, you set the parameters of how far between two settings that you want the wizard to look at to hit that target using 2-second exposures, or you could make it 3 seconds or 1 second, whatever. So again, when you hit the go button, Nina will calibrate the exposure of your flat panel so that it meets that requirement within 10%. This is doing it in single mode. If you've got multiple filters like I have, you can set each filter to do exactly the same. So some filters may take a different level of brightness. So for instance, my luminous I know is somewhere between 20 and 40 to reach after 1 second my target of 50% along the histogram. So having set that for my luminous, I would then set each filter accordingly and then hit the go button. Because it's only set to take it in 1 second, and to be honest, once you've run this, you'll get an idea of where your brightness tolerance is. That this whole process, I can get 7 filters run in a matter of 2 or 3 minutes. So the next item on the menu that we haven't looked at is, we've done sequencer, we've done imaging, is the options main menu, which gives you 6 sub-menus. I'm not going to go through each one. There's plenty of good instruction in the Nina handbook, and also there's plenty of good YouTube videos show you how to configure Nina to however you want it to work. One thing I'll point out is it's got a whole section on configuring a dome, so if we ever get a observatory, this is the ideal piece of software to control the dome. And the final thing is plugins. And you get 2 items in your plugins menu. The first one is what's already been installed, which gives you the option to uninstall it, or if there's been an update on the plugin, you'll see it there that you can update it. So the sort of things that plugins do, let's look at one of them. I've got target planning. So if I wanted to find the next time that M1, the Crab Nebula, is going to be available to me, I can say that I want it at a minimum altitude of, for my horizon, say 30%, and I want to be able to image it for at least 3 hours, and I want to start after astronomical darkness. So when I hit this, it will give me the times and dates of when that target is going to be available. So the first time it's going to be available is tonight at 9:38, and it'll be available until almost 6 o'clock in the morning. It'll give me 8 hours of imaging time. However, the moon is going to be illuminated at 62%, and the target is 41 degrees off the moon. Pretty strong tool that. When I look at all the other things that are available, there is a long list. It's what makes Nina such a powerful tool, that you can do all sorts of things, and so one of the tools which I use is called Lens AF. What that allows me to do, and it describes it here, this plugin provides a focus driver for lenses attached to a Canon camera. So what I can do is attach my Canon camera to my mount, and with this plugin I can focus, use it to focus either with the automatic focuser or manual, or focus it by eye. So it's given my camera almost the ability to become a smart telescope. If you're planning to leave your telescope unattended, this is a cracking tool. You need to install or buy a subscription to, I can't remember what it's called, it's on here somewhere, Pushover, and it costs you $5 for a lifetime license, so it's not going to break the bank. And what it does is you can use it with the advanced sequencer, so if a condition is met, it will send you a text message to your phone. So it would wake you up in bed if, say, it's suddenly become cloudy because the HFR readings have gone way through the roof. What I would suggest you do is, when you've installed Nina, is go through all these plugins and have a read of them, and some of them have a website where you can go and read more information, probably a tutorial video about it. Very strong tools. A lot of the plugins are relevant to the advanced sequencer, and one which I could point out here is called Orbiculum, if that's how you pronounce it. And the example here it gives is, you know that a target is obstructed until it reaches a certain altitude. So you want to loop on another target for as long as that other target is below that specific altitude. So if I want to target M1, but it doesn't become available on my horizon until it reaches, say, 40-degree altitude, I could have Nina continue looping to take a set of images of another target until that condition is met, and then automatically it would go to that M1 as a target. So we'll just have a very quick look at the advanced sequencer. So the advanced sequencer is it's like a scripting tool where you can build a script for a set of instructions that are going to be carried out during the sequence that you're planning. And once you've completed the script, you can then add another script, so that you could have multiple scripts running throughout the night. So just to give you a quick example of what's available, so if I go over here and look at instructions, there's a whole lot of instructions and conditions, triggers and things that you can use. At the top you can search for something, so if I'm looking for a weight instruction, they will appear because I've searched for it. I'll just clear that. There's 5 areas of the script to consider. The first is what the sequence is going to do at a high level. So it could be an instruction to, with the camera, to cool it, turn the dew heater on. You then have global triggers, and these are events that may happen during the sequence, or you'll tell Nina what to do in case of that event. So the event could be a meridian flip. So if I put meridian flip in, I can then add some instructions of what to do after a meridian flip. So I may want to run the automatic focuser again, or do a plate solve to make sure I'm correctly on the target. That leaves 3 other areas, and that's the start area, and jumping ahead, the end area, and the middle one of course is what's going to happen and to take the sequence. And it'll probably start off with one of these loop conditions, so it may loop for a number of iterations or loop until a certain time has been reached. To make life easier, there's a set of templates, and at the top here you've got 3 basic templates for the startup, the end and the middle section, which is the main loop of taking exposures. To make life even simpler to that, there are specific templates, like this is for a mono camera using luminous red, green and blue. So if I pull that across, it enables me just to put a target name in, and then I'll scroll the way down. Here's the actual looping section, so I can tell it that I want to take 120-second exposures of lights, binning 1:1, with the usual gain, but the filter is going to be luminous. I'll call it filter 0, and the next one's going to be filter 1, and the next one's going to be filter 2, and the next one filter 3. So that's very quickly and easily set up my system to run this loop, and I can't remember how many times it's going to run. It's going to run 10 exposures of each for 120 seconds or 2 minutes. Hit the go button and go and have a cup of coffee and come back in whatever time it takes to run. And I think that's it, folks. Install Nina, look at all the plugins that you can add, and watch a video about the advanced sequencer and how you can use these templates. That's it, and it's a good night from me.